Okay, so basically this entire section kind of comes down to being able to solve quadratic equations. Okay, we solved them by graphing. Okay, then we worked on factoring, which gave us the ability to solve equations. Okay, well, another method of solving quadratic equations is by a method called completing the square. Okay, so in order to kind of start this off, I want to do an example of factoring. Okay. Yes, take notes on this, yep. Okay, so if I asked you to factor this, which method could you use to factor it? The easy method, right? So I'm looking for two numbers that multiply to 36 and add to 12. 6 and 6. Okay, so did everybody notice that the two quantities, whoops, I don't know where I got a 2 from, my bad. The two quantities were exactly the same, so I can just write it as squared. Okay. So this is kind of the foundation of completing the square. Okay. Basically, what we're going to be doing is we're going to create this perfect trinomial, perfect square trinomial, so that we can get to this spot. Okay. Because let's say this was set equal to 0. How would I solve this at this point? Okay, so let's pretend I wasn't going to set the quantities equal to 0. Let's use a different method. Okay, how would I solve this algebraically? Okay, if I have a quantity squared, how do I get rid of the square? Square root it. So I could square root this, and I would be left with x plus 6, and the square root of 0 is 0. And then what would you do? Subtract 6, right? So we would all agree that x is equal to negative 6. Howdy. Thank you. Okay, so that's basically where we're going to be going with all of this. Okay. All right. One solution? No. Good question, but no, just in that case. Okay, so this is the first thing I want you to write down. Okay, and this is called a special case. Okay, and the special case is basically, whoa, that is a typo. See this 2 right here? That should be on the outside. Should be a what? Alright, no, that's not there. That needs to be, hold on. This is a typo, but it should be a 2. It should say a squared plus b squared is equal to a squared plus 2ab plus b squared. Okay, so in case you were wondering what that's called, it's called a perfect square trinomial. So if you hear me reference that, that's where it's coming from, perfect square trinomial. Okay. All right, so basically what this does, this is going to kind of walk us through being able to factor. Okay, so in order to complete the square for a perfect trinomial, we're going to have this piece right here. Okay, so we're going to have x squared plus 4x. Okay, so what number would be added to that in order to have a perfect squared trinomial? Okay, so what would my constant value be? Okay, so if you think about it, two numbers have been added together to make 4. Two numbers that have been added together to make 4. What's that? They have to be the same number. Okay, so 2, right? Two numbers added together, and then they square it. Okay, so 2 squared, right? So 2 squared is 4. So basically what they're getting at is the number that we're always going to use to add is going to be b divided by 2 because we have two numbers that have been added together. And then when you multiply 2 times 2, that's the same as 2 squared, right? So this is how we complete the square. Okay, so I want you to write this definition down. Okay, so let's do an example. Everybody have that written down? The b divided by 2 squared part? Okay. Okay, so let's say, I don't like how they have these little missing pieces. Well, let's just come over here. Whoops. So let's say we have x squared, what was it, minus? Yeah, let's do minus. Minus 8x, okay? What is the number that we're going to add so that it becomes a perfect squared trinomial? Okay, so our work is, so I'm going to say for our c, we're going to take the b value. What's the b value? -8, so we're going to take -8, we're going to divide that number by 2. Okay, so everybody thinking -4? And then, because -8 divided by 2. And then all we're going to do is just square that. So what's -4 squared? 16. Okay, so do you see how this perfect squared number is 16? So now let's think about this. Is this a perfect squared trinomial? What two numbers multiply to 16 and add to -8? -4, right? -4, -4. So this factors to x minus 4 squared. Okay. Should we do one more? One more, okay, one more. There we go. This one. Okay, so where do I start? How do I find my c value that I'm going to add to both sides? Oops, I said something I shouldn't have said. So 12, and I divide that by 2, so everybody thinking 6, and 6 squared is 36. So if I have x squared plus 12x plus 36, what does that factor into? What two numbers multiply to 36 and add to 12? Oh, that was my first example. Math people are not creative, let's just say. Okay, so how does this help us solve quadratic equations? Okay, so we're going to do this and actually solve. I'm actually going to go down to the very bottom and, because I don't like how they do all this for us. It's helpful if you don't have a teacher, I guess. Oops, I don't like those either. Nope, just kidding. There we go. Hold on, wait for it. There we go. Okay, so we're working on question number 5 here. Okay, so I don't know if you want to call this example 4. Okay, so in completing the square, the first thing that we want to do is we want to have the 2x terms on one side and the constant on the other side. So we're kind of ignoring this side for a second. Okay, so remember what we just did where we completed the square? Okay, so what number am I going to add to this to make it a perfect square? Okay, so I'm going to take 8, right? So my c value, I'm kind of thinking this off to the side. So I'm going to take 8 and I'm going to divide it by 2. So everybody thinking 4. And then if I square 4, what's the number we're going to add? 16. Okay, so that's my perfect squared number. So, whoa, sorry. So I'm going to add 16. So my left-hand side is a perfect factor. But if I'm solving an equation and I add 16 to one side, what do I got to do to the other side? I got to balance it, right? Okay, so I have to add 16 to both sides. Okay, Now on my left-hand side, I can factor this. It's a perfect factor. Okay, what two numbers multiply to 16 and add to 8? 4, right? 4 and 4. So this becomes x plus 4 squared. And then on the right-hand side, everybody follow that I'm just going to go ahead and add those two numbers. So 33 plus 16 is 49. Perfect. Okay, now I'm going to solve this algebraically. How do I get rid of a square? Square root. So my next step is I'm going to square root both sides. So what's left on the left-hand side? Sorry. My palm hits that bottom toolbar. Okay, on the right-hand side, what is the square root of 49? And be very careful. Plus or minus 7. There's technically two numbers on that side. I have a positive 7 and I have a negative 7. Okay, now, what is my last step in solving for x? Subtract the 4, right? Okay, so this is what I need to be thinking. I have 7 minus 4, and I have negative 7 minus 4. Two different things. So what is 7 minus 4? 3. Okay, and what is negative 7 minus 4? Negative 11. We just solved a quadratic equation. Awesome, right? Shall we do another? Okay, yeah, that was kind of a rhetorical question. I wasn't really going to let you say no. We're going to do a couple, because there's a couple different scenarios that have to play out. All right, so if I'm working on number 6, okay, the first thing I need to do is complete the square. Okay, so I need to add that c value so I can make a perfect factor. So what is the number that I'm going to use to get there? So I'm going to take, what's my b value? Negative 6. So I'm going to take negative 6 and I'm going to divide it by 2. So what is that? Negative 3. And what's negative 3 squared? 9. Okay, so what am I going to do with the 9? Good, so good Lord. We're going to add 9 to both sides, right? Okay, now my left-hand side becomes a perfect factor. Okay, so let's factor the left-hand side. What two numbers multiply to 9 and add to negative 6? 3. Close. Technically, maybe we're thinking that. So x minus 3. Okay, on the right-hand side I have 8 plus 9, 17. Okay, now what do I do? Okay, good. Now I'm square rooting both sides. So I square root. So my left-hand side turns into x minus 3. Ooh, what's the square of 17? So the square is 17. Yeah, you can't break it, so we're going to leave it. We want things to be exact. Okay? Now technically, because I'm solving an equation and I'm taking a square root, what do I need in front of that? Plus or minus. There's two numbers there. So we have a plus or minus square root of 17 here. Now what's my last step? Add the 3 over. So when I add 3, watch how I write this. Okay, what's happening here is I have a complex solution. I'm going to write the real number first and the radical last. Okay, so notice this says 3 plus or minus. That's adding and subtracting in between the radical. Okay, don't move that in the front. You'd be surprised how many people will do that, and it's like, you got that far and then you did that? Okay, so this is what we're going to do. Everybody's logged on to Nearpod, yeah? I got a code. There we go. There's the code. If you haven't got the code, go ahead and get the code. Alright, so what is different about this question number 9 versus the last 4 questions that we've done? Yeah, there's a number in front of the x squared. Okay, so we cannot complete the square. Shh. Everybody taking notes right now?
Oh wait, yeah, I love taking notes.
Notes. You want to write this down in your notes.
Yeah, no, in our notes.
We just switch because it's a different problem.
Because this one is confusing.
Okay, so I cannot complete the square if there is a number in front of the x squared. So, how can I get rid of it?
Square root. Wait, what'd you say?
Divide.
Divide by 9.
Okay, so see how there's a 9 in front? Okay, everybody follow with me. This is going to be a little bit awesome. 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 Okay, so when I divide by 9, I have to divide every term by 9.
Which sucks because they're not divisible now.
Okay, so what does my first term become?
X squared.
X squared. What does my second term become?
4 thirds.
Okay, now, we need to keep things as a fraction. Okay, so I have 12 divided by 9, which is the same as 12 ninths.
Which is the same as 4 thirds.
What can I reduce that to?
1 third.
Good, 4 thirds. Can I reduce 32 ninths?
Yes.
Yeah. Would it be
3, 8, 3.
No.
I don't know then.
Keep it as, no,
You gotta
you
leave
cannot
like
reduce
that?
it. Yes.
Good.
Okay, so now what do I do if I'm completing the square?
So you take divided by
I take the b, I divide it by 2, and we're going to square it. Are you ready? Okay, what's my b value?
4 thirds.
4 thirds. Whoops, excuse me. Oh, good lord.
Oh boy. I'm Cortana.
All right, so 4 thirds, and we're going to divide by 2, and we're going to square it. So how do you take 4 thirds and divide by 2? Okay, did you know all you have to do is just multiply the two numbers that are in the denominator together?
No.
Okay, 3 times 2? 6. This reduces to 4/6.
You joke. 36.
Not
I love
joking.
my life.
Okay, and if I reduce 4/6, that is 2 thirds. And now I have to square 2 thirds. So how do I square a fraction?
You roll
Add
with
that
it.
little 2 at the end.
You just like square the top,
You just roll
and you square the bottom. So on the top I have 2. What's 2 squared?
4.
4. And on the bottom I have 3 squared.
Why is it 2 outside the parentheses?
Because I'm squaring things.
So is that a
What's that?
Is that
That's the C value.
I have no idea what you said.
Yes. Okay, so now what is the number that I'm going to add to both sides?
4 9.
4 ninths. So I'm going to go back to my equation and I'm adding 4 ninths. Everybody following?
You know what? Yeah, I do.
So we're adding 4 ninths to both sides. We good back there? All right, so now on the left-hand side, I need to factor this. Now remember, the whole purpose of completing the square allows it to be a perfect binomial. That means both of the quantities are exactly the same. So what two numbers multiply to 4 ninths and add to 4 thirds? They are the same number. 2 thirds? How did you get that?
I just rolled with it.
Because it's the number after you divide.
What, Kayla?
It's the
2
number
times
after
2 is
you
4.
divide.
Wait.
Whoa.
I'm not making the connection, so. What?
Calm down.
If you go back through all of the examples that we have done, this little trick will always hold true. Whatever this factors into comes from the number that you divided by 2. Before you squared it.
Hold up. Wait.
What?
Whoa.
Oh.
That's so easy.
Why did you not?
I'm literally crying.
We gotta have value.
I've been
Have
using that
value.
since I learned about it. I didn't realize I was using it.
Okay, on the right hand side, can I add those two fractions together?
Yes.
What's 32 plus 4? 36 ninths. Okay, now what's my next step?
Square.
Square root it. So what's left on my left hand side? Okay, and how do you square root a fraction? We're going to leave it. Technically, yes, but I'm not going to. I'll show you why. Just like squaring, you square at the top and you square at the bottom. So on the top, what's the square root of 36? And the square root of 9 is 3. Okay, yes. Now you guys are all yelling at me like, well, can't you just say that that's just 4 and the square root of 4 is 2? Okay, yes. But the reason I'm not doing that, can I show you why? Because what is my next step?
Subtract 2/3.
Subtracting 2/3. And you see how when you add and subtract fractions, you want to have a common denominator? Okay, I want to keep the denominators the same. So if I start reducing, the denominators will become unlike. If I don't reduce, they stay the same. Okay, all right, so let's subtract this 2/3. Okay, now remember I have two scenarios here, right? I have 6/3 minus 2/3, which is 4/3. And I also have negative 6/3 minus 2/3. What's that one?
Oh, wait, we're still going.
Negative 8/3. Okay, so this one gives me two different solutions. Do you want to do one more together?
Yes. Okay.
I think that we should try it, see how.
So you want to do it through Nearpod and try it that way?
We'll try it.
Okay.
Negative 8/5.
Actually,